All right, we're live. Oh wait, hold up. Sorry, your audio is not on. That's me. That's me. Let me figure it out. It should be. Hmm. Give me a second. Talk.
Hello, hello. One,
All
two,
right,
three.
we're
One,
good.
two, three. We're good. We're good.
Yeah.
We are good. We're back. Yes, yes, yes. We're back again for another live stream. Another LeetCode problems. The last live stream of the Christmas break. That's
Christmas.
that's what Christmas winter break. Before we go back to school. That's where we are at right now. How do you feel about that, Carlos? You
I feel
excited to
really
go back to
excited.
school?
Yeah.
Yeah.
Mm-hmm.
Alrighty,
I
alrighty.
need to, bro. Like, I don't know what to do without school.
Facts, facts. Now I
Like,
get you.
I get all my things done in the day, and then
Yeah,
once that's done, like, what do I do?
yeah, exactly. I personally get. I don't know if you get it, but I get this feeling of like laziness and like very, like not like disappointed because I felt like I could be doing more with my day. But like you said, like once we finish everything, right?
Yeah.
You know, there's nothing you can do, right? So,
No,
but
like
hey,
I feel the same exact way. Like
yeah,
once I get all
yeah,
my
yeah,
stuff done, you still got time left in the day, like
yeah,
so usually I'm just like I get in my head in a way that I'm like, damn, like I need to be doing more or you
yeah,
know.
yeah, yeah. I
So
get you. I get you,
it's
yes,
weird. It's
sir.
definitely weird. It's like,
It's a weird feeling. Yeah.
yeah.
Yeah,
But
no, and
what are you gonna say?
but we're oh no, no, but like you said, I'm excited to go back to school, get that routine back again for sure.
Yeah.
Yes, sir. And I know we
We're
got one or two classes together. I'm not sure. I know it's
I'm
operating
pretty sure we
systems.
got 3 classes together.
Three classes. All right, okay? I don't know if you want to verify
Is
that
it
right now. Let me
database
see.
systems?
Yes, you got with webs,
Do you know what time yours is?
2:30 to 3:45, Tuesdays
Yes.
and Thursdays. Okay. I know we got
Operating systems.
operating systems
That's 1
and
p.m.
programming languages. Let me see. Yes, 1 p.m. to 2:15. Yes, yes, yes.
Oh no,
What
we got
about
two. We got 2 classes.
just two classes?
Yeah,
Okay,
yeah.
okay. Yeah. Alrighty. Okay, okay, okay. Not bad, not bad. I'm excited. Yes, sir. I was scared because I know our schedules is kind of like deviated this semester, so I was
Uh-huh.
scared I wasn't gonna get like that much time with you, right? Or classes with you. So,
Yeah.
it gets some lonely right there when you don't have nobody to talk
Hey,
to,
that's
you know?
true.
So,
It's all
yeah,
good,
so,
man. It's all good. I
yes,
think
sir. So
we
we're
built
here
a
though.
great foundation to where we're always
Exactly.
on. We can always call each other anytime. So,
Exactly. Yes, sir.
um, but other than that, I think I'm ready, man. I'm ready to tackle
Hey,
these damn problems, man.
yes. Yeah, I'm ready too. You're
All
down.
right.
I'm ready to go into it, and see where we go, see how far we can go.
As y'all can notice, we're also 30 away from our goal.
30,
30
yes, sir.
subs.
That's 500, 300, of 500 that's your goal. Yes, sir.
Yeah.
Yeah, I'm
So we're
excited
almost
about.
there. We're almost there.
We're almost there, baby.
And
We're almost there.
we're 5 weeks, I think, away from hitting a year.
And year.
Yeah.
Ooh.
A year of
Okay.
streaming. So
Year. Oh,
that's gonna be a big deal. Gonna be a real
yes,
big deal.
sir.
But
Yes,
where we left
sir.
off on our dynamic programming was the longest increasing subsequence.
Yep, yep.
And I believe we have an escalar draw for that. Here it
Yes, sir.
is.
We got a schedule draw right here. Just for
Honestly,
us.
bro, I
Yeah.
don't remember where we're at last time, so I don't know. You
Uh,
gotta you gotta
okay,
jumpstart me.
I got you. Yeah, I got you. So last time we finished, what's it called? Let me see. We finished word break, which was the one where we had to break the word and see if we could make what's it called? Like the word based on the dictionary or something like that.
Uh-huh.
So we finished that one. It was pretty cool, pretty chill, pretty nice, straightforward, into the point. Pretty nice problem. And now we're into our last problem of this section called longest increasing subsequence. To be honest, I haven't done like any research or any stuff on this problem. I'm going in there blind, right? But as
Oh,
it
I'm
looks of it,
sorry. Is
looks
this
yo,
is this the same as the one we worked on last time, or this is a new one?
this is a new one. This is a new one.
Oh, see, look,
Yeah, this.
that's how far off I am. Like, I thought we didn't finish the one last time.
Oh, no. Yeah, we finished the problem last time. This one
Okay,
is,
so
yeah,
this
we
is a
haven't
new
even
one.
touched it. New one,
Okay,
brand
okay.
new. It's sir straight out
All
of the
right.
package. So I'm excited for this one. We'll see how far we can go, and hopefully we can finish this time. So we're going in there blind, and yeah,
Okay.
if you're ready, I can read it if you want.
Yeah, let's get it going.
Yeah. Alrighty, so this is problem 300, longest increasing subsequence, and it's a medium, and it says the following. Given an integer array nums, return the length of the longest strictly increasing subsequence. Example 1, nums, we're given input of nums that has 10, 9, 2, 5, 3, 7, 101, and 18. The output is 4, and the reason is because the longest increasing subsequence is 237 101. Therefore, the length is 4. Example 2, we're given an input of nums of 010323 and output of 4, right? And I'm assuming it's because the subsequence would be 0123, right there. So we see the 4 in there. And example of input nums is we get how many seven sevens. The output is 1 because seven sevens sevens. If they are the same, there's no increase, there's no decrease. It's the same. Constraints, right? With the nums length is between 1 and 2500, and the nums are between negative 100 to the power of 4 and 100 to the power 10 to the power of 4. We're also given a follow-up question, but let's first focus on the main question, which is solving this problem recursively. And so,
Whew.
yeah,
You
that's
know, I don't
yeah.
I don't know why I'm gonna say this because it doesn't really help us, but I was watching a video
Uh huh.
talking about this problem.
Oh, really?
Like,
Okay.
it wasn't specifically for this problem, but it was like a
Yeah.
video that I thought sounded interesting. It was like talking about dynamic programming,
Yeah.
and all that to say is I forgot what it talked about. So that's why I said I don't know why I'm bringing it up, but
Hey,
it
I'm good,
definitely
brother.
it definitely talked about this problem. They said like um you know how they always say like, oh, it's one of the core problems that shows an example of dynamic
Yeah.
programming and stuff. Actually, I
Yeah.
think something I do remember is there was like this interesting way to trace or to visualize recursion,
Okay. Yeah, for sure.
and it's like let me try to remember it.
Yeah.
It's like if you have like all the possible ways. So like 10. Hold on, let me see. It'll be like there was a specific word for it, but like 10, and then it goes over here, and then 9. Higher than 9 is this one,
Mm-hmm.
and higher than 101 there's none, and then 2. Higher than 2 is 5, and higher than 5 is 7. Higher than 7 is 10. So there was like it's basically like a brute force visualization,
Okay. Yeah.
but
Yeah.
it basically showed you like
Like a
like
starting point.
what you could ignore,
Okay.
since
Okay.
like I don't know really how to explain it, but it's something along the lines of that where it's a
Yeah.
specific way you could map a problem
Uh-huh.
to kind of give you a better understanding of um how you could formulate your sub problems.
Okay. Yes, yes, yes.
So because like the goal is to break it down to solve the sub problems, and then use the sub problems to solve the big problem.
Yes.
So
Yes.
it was something along the lines of that. But anyways, like I
Okay,
said,
okay.
I don't remember that quite a bit of it, but
Yeah.
I was hoping that
Hey,
if
I mean,
I did the drawing that I could refresh my mind, but it didn't work enough.
hey, no, I mean, like you said, I like the way you kind of like mapped it out and the way you started to approach the problem because I think you were going the right path, right? And like you said, we can scratch it out, scratch it in and see what things we can ignore, the base case and all that stuff, right? So, if you want, we can start drawing it out and see see the patterns or any piece of logic that we can find that can
Okay.
help us. Yeah.
Yeah.
Alrighty. All right. So, what do you think, brother? What's the plan of action?
So
Yeah. Let me see.
like it was like this, bro. Like it was
Okay. Okay.
like imagine it was like a 5, 4, and then a 2. Like it
Yeah.
showed
Like a
what
tree.
yeah, like it showed
Okay.
what the possible paths were. And for example, let's just say 4 didn't have a path to 2, so it wouldn't show like that. And then let's say there was like another number, maybe like a 7. These numbers are not related towards the problem, but I'm just giving you. I'm just trying to
Yeah. Yeah.
remember. And then like this one will go here though, and this one can connect to this one, and then you're like, okay, well now this is the longest one. Like I don't. I wish I could just like watch the video real quick and then just like remember it, but
Hey, if you
the
want, we can
video.
you can watch
Here's
it.
what the
You
video
know.
was. Here's what it was about. Here's what the title said.
Okay.
Uh, how to, it was called "How to Solve Dynamic Programming Problems,"
Okay.
or like
Okay.
how to break it down, or
Mhm.
so yeah. It also
I
talked
mean,
about like visualizing it in like like boxes. No,
okay.
never mind, never mind. That was actually a specific problem.
I mean, how
I don't
long
know what
is
I'm
it?
talking about, bro.
Cause
No, I don't know. I don't know. How long is the
I
video? You know what? Let me find it. Let me
yeah.
find it. You know what? You could
Yes.
talk.
Yes.
Let me find it real quick.
Alrighty. Yes, sir. Alright, so we got some people in the chat. Ali, hello. Hey, welcome back, Ali. Thank you for tuning in. Happy to see you back again. We're 30 subs away. So please, sub in, share, give it a like so we can reach more people. So please leave a like, share, subscribe. 30 people. Yes, 30 more. 30 more. Alrighty, so let's see. Let's break this problem down a little bit. Um, I like the approach Carlos was doing though. Like the 10, going here, 10 9, 10
All
2,
right, I got the
10
problem.
5. Okay.
So, I mean, I got the video. Do you mind if we maybe play a little snippet?
Yeah, I'm down. Are we gonna get
Okay.
copyrighted?
Uh, I don't know. I don't care.
Oh no. Alright, let's go for it. Yeah, for sure.
So it's 5 steps to solve this one.
Okay.
All right. Uh, You probably can't hear it, right?
No, I cannot.
Give me one moment.
Yeah, take your time. Take your time.
Can you hear it?
Yes, I can hear
All
it
right.
now. But we can hear, I think, your music a little bit.
Centers around the idea of
There you go.
solving a problem by first identifying and solving subproblems, and then bringing these subproblems together in some manner to
Okay.
solve the larger problem. Not surprisingly, this process is easier said than done. In fact,
Okay. I'm gonna skip a
dynamic
little bit.
programming problems can be
Yeah, yeah, yeah. You
Actually,
go for
two
it.
times speed.
around. In this video, I'll walk you through 5 steps that you can use to help discussion of general dynamic programs. First example we'll look at is the longest increasing subsequence
Oh, it
problem.
looks a little.
Imagine
Oh,
you're given a sequence of n elements,
that's
and you want to find the length
this
of the
is
longest
the
increasing
problem
subsequence.
that we're solving.
Yeah, yeah, yeah.
Yeah,
The
okay,
longest
okay, okay.
subsequence is
Fair.
just a sequence of elements where each subsequent element has both a larger value and index than the previous element. Here are some examples to clarify what I mean here. Given the following sequence, the longest increasing subsequence is 1, followed by 2, followed by 5, with a total length of 3. Now that the problem is more clear, take a second to see if you can find the longest increasing subsequence and its respective length for the following sequence. The correct subsequence starts at 2, followed by 3, 6, and 9, with a total length of 4. Now, one important note for this problem is that, to keep things simple for now, we will focus on finding the length of the sequence rather than finding the sequence itself. The first step in solving dynamic programming problems is to find a way to visualize examples. Visualization is a great way to see connections and underlying patterns in the problem that can later be relevant to the solution. When solving this particular problem, we clearly have some restrictions on valid sequences, so it makes sense to find a way to diagram out what makes a valid sequence. A nice model that shows up all the time in dynamic programming is the directed acyclic graph.
There it is. Directly. What did it say? I already forgot.
Asynchronous.
Clearly have some restrictions on valid sequences, so it makes sense to find a way to diagram out what makes a valid sequence. A nice model that shows up all the time in dynamic programming is the directed acyclic graph.
Acyclic
Yeah,
graph.
acyclic graph. Yes.
Okay,
Okay.
now this is the part where I think it's important.
Each element of the sequence is
Alrighty.
a node in a graph, and we construct a directed edge from one node to another if the node on the right contains a larger value. Here's what the directed acyclic graph representation looks like for this particular input sequence. What's nice about this representation is that an increasing subsequence is just another path in the graph. In fact, going one step deeper, the length of the longest increasing subsequence corresponds to the length of the longest path in this directed acyclic graph, plus 1, since we are technically counting nodes. Solving this particular problem might be a little bit more clear, and sometimes this shift in perspective is the key to making challenging problems more approachable. The next step for solving a dynamic programming problem is to find an appropriate subproblem. A subproblem is basically a simpler version of our overall problem. Finding subproblems can be tricky, but let's focus on what we know about this problem. We know the longest increasing subsequence is going to be a particular subset of our initial sequence. One way to specify the subset is through the starting point and the ending point. Every increasing subsequence, no matter how long, will have a starting and ending point within the original sequence. So let's modify one of these variables to create a subproblem. Turns out that you can solve this particular problem with either choice, but I personally find focusing on the ending point of a subsequence as a little bit more intuitive. Let's define a subproblem for the sequence as LIS at index k, which would mean the longest increasing subsequence ending at index k. For example, the LIS ending at 3 would be the sequence starting at 1, followed by 2, which has a length of 2. Remember that when I am referring to LIS in this particular problem, it is specifically with respect to the length of the sequence. Okay, so now that we've identified one possible subproblem, the third step requires finding relationships among subproblems. It often helps to ask yourself questions in this phase. For example, suppose you want to solve the subproblem of finding the longest increasing subsequence ending at index 4. What subproblems are necessary to solve this? Well, the nice thing about this graphical visualization is that it makes it quite clear what subproblems we need. One path through index 4 must go through index 0, so we will need to know the length of the longest increasing subsequence ending at index 0, which happens to be 1. Another path comes through index 1, so we'll need that subproblem as well, which also has length 1. The final possible path ending at index 4 goes through index 3, and the longest increasing subsequence ending at index 3 has length 2. Now the nice relationship here is that the length of the longest increasing subsequence is just going to be 1 plus the max over all the necessary subproblems, which ends up being 3. And this should intuitively make sense, right?
Interesting.
Okay.
So 1 plus the max of. Yes, I guess that makes sense. Because you're counting the nodes. So 1 is the 5 plus the max of the paths of these, and the max would be 1. Or
if I want to find,
what would the max be? Yeah, 1.
it'd be 3.
Because Okay, well, I don't know. I'll keep it going.
Longest increasing subsequence ending at index 4, it does make sense that I would just add 1 to the longest increasing subsequence over all subsequences that eventually arrive at index 4. So once you've found a reasonable relationship among subproblems, we want to then generalize this relationship. Let's look at our other example and see if we can come up with a similar process to solve the longest increasing subsequence ending at index 5. The key idea here is that we're going to choose subproblems ending at index k if and only if k is less than 5 and the value at index k is less than the value at index 5. Seeing this relationship in action, we start at k equals 0, and since the value at index 0 is less than 6, we need to know the answers to this subproblem. And we continue to go through all possible k values less than 5 and include subproblems that satisfy the constraints laid out by the problem. And in reality, there's nothing special about index 5. This applies for any n. So the general relationship for finding the solution to a subproblem of the longest increasing
Interesting.
subsequence ending at index
Okay, I
k
see.
is 1.
You get it?
Okay. Yeah, I
So
that made it a lot
all
better.
the paths that connect to n, you just go through them and uh, oh, actually, you get the max of it. Let me
All
see.
k
It's
is
like
less than n,
okay.
with values at index k less than values at the index n. Now we are ready for implementation, which is the final step. Implementing a dynamic programming solution is just a matter of solving subproblems in the appropriate order. What's most important is that before solving a particular subproblem, all the necessary prerequisite subproblems have been solved. In this problem, the order is actually fairly straightforward. We have to solve the subproblems from left to right. So let's now implement a function. Let's keep track of the lengths with a list. We can initialize all the lengths as 1, since every increasing subsequence will have at least 1
Sorry, I
length.
need to pause it real quick. We just got one more sub. Hey, hey, hey,
Hey,
hey, hey,
hey,
hey.
hey, 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 hey.
Then, for every
Yes,
increasing value in
sir.
the length of the input list, we will first find the necessary subproblems, and then we update the length according to the generalization that we have specified. And then at the end, we return the maximum length over the entire list of lengths that we have just updated. There are many ways to implement this function, so don't get too bogged down in the details. The important thing to remember here is the thought process we use to identify and solve the subproblems in the right order.
We've got passion, we've got
Whoa.
determination. Like, and if we
Whoa,
start
whoa,
making
whoa, whoa,
mistakes,
whoa, whoa,
you
whoa,
know,
whoa,
we're
whoa,
just
whoa.
There's one last important question we should address. Everything we have done so far has been specifically with respect to finding the length of the longest increasing subsequence. But how do we actually find the underlying sequence? The key idea here is actually fairly simple. All we have to do is keep track of the previous indices for a particular subproblem. More specifically, if I solve the longest increasing subsequence ending at index I subproblem using the value of the longest increasing subsequence at index j, I can say that the previous index of index I is index j. Let's look at a specific example for some clarification. In this sequence, the previous index of index 0 can be labeled as -1 since there's no previous sequence value that leads to index 0. Same can be said about the previous index of index 1. For index 2, the previous index is either index 0 or index 1, and it doesn't really matter which one we choose since they both have the same length values. For the previous index at index 3, there's only one choice, index 1. Finally, index 4 actually only has one choice because the subproblem that's used to calculate the length at index 4 is the longest increasing subsequence ending at index 3, so the previous index is subsequently also 3. This type of pattern with tracking previous subproblems is a common trick used to solve dynamic programming problems. Let's now take a look at a more challenging problem.
All right,
Here's the
that
problem.
was it.
You're given
Do you think?
Okay.
Do you think?
I think it gave us a better perspective on the problem, how to see the problem a little bit better.
Do you think we
Um,
can't? But the trick, or not really the trick, but the step that he mentions is that that visualization graph.
yeah, the acyclic graph or something like that.
Yeah.
Yeah. I see it. I see it. Okay.
Could that help us or no?
That helped me understand a lot better. Yes, for sure. I'm actually gonna try and draw it out of here and see
Uh,
we can do. Okay, this. Give me a sec. So we got 10, 9, 2, 5, 3, 7, 7, 1, 1, 18. Okay, so I got it right here. Yay or nay?
yeah, yeah.
Yeah. Okay, so basically what he said is that length n, right? Well, the length, the LIS, right, of n is gonna equal to the substring where the element n, or let's say index I, is less than n, pretty much. Something like that. I don't remember that much, right? Um, hmm, not sure.
So the graph for this example would be
10,
this,
18,
and
let's see,
then
2, 3,
this,
2, 3, 5, 7.
this.
Something like that, no?
Wait, Control Z one time. There you go.
I'm just gonna make this a little bit.
There you go, and then another one there. 5, 7. Oh, remember it's. Oh, isn't it like?
Oh, it can. Okay, so it can go to various. Okay, that makes sense. Yes. Yeah, yeah, yeah. Okay.
Just looks ugly now.
I'm not sure what I'm looking at, but no. What he's trying to say, I think, is that, for example, let's take 7, right? 7. Because there's also. Let me see if I can copy it over here. Yeah, right here. So, for example, let's take 7. 7, we know it goes to 101 and 118, right? 5 can go to 7, right? Or 101 or 18. 2 can go to 5. 2 can go to 7. 2 can go to 101. 2 can go to 18, right? But if we delete all of these specifications, we see that, and 101 can only go right there. So if we delete the redundant ones, oh, my bad, right? 7 can go 18. For example, if we see 7, right? 7 can go to 101 and 18, right? 2 can go to 5, right? Right? And 5 can go to 7 or 101 or 18. 2 can go to 5, 7, 101 or 18. So you can see it's like you're building on top of what you know already. I don't know if that makes sense. Because for 7, so let's say if we go at 7, 7 is going to be based on 5 and 2. Yeah or nay? Yeah
Yes.
or nay? Yes? This is
Well,
yes?
remember how the guy kind of mentioned it was that like you you have this,
Yeah.
and then you scoot it, or should you go from? Oh, maybe you start from the right, and you say like, okay, what are the paths of this one?
Uh huh. Yeah. I can see that. I can see that.
I lost it.
No, I think what he was saying, it was something. So like this, you had the 10 and you expand it to the right a little bit. Like 10 and 9, right? 10 and 9, right? This one only has 1 and this one only has 1, right? Because 10, you start at 10, but you can go nowhere. You start at 9, you can go nowhere, right? But if you keep moving, 2, now you're well, here 2 only has 1, 2, right? Because 2 cannot go anywhere. And then if we delete these right here, now you add 5. Now things start to change because 2 can go to can have a length of 2 and 5 of 1, because 1, 2 can go to itself and 5. right? So you're touching two nodes or two numbers. So that's a length of 2, right? And then you keep expanding it. You go to 3, right? Now 2 has two options, either go to 5 or go to 3, right? Hmm.
But isn't this like a brute force? So where's like the storing it memo?
Yeah, yeah. Ufas. I mean, we'll see. Cause you can do it. Damn. Not lie, bro. I'm in the same boat as you. I already forgot what I heard. What I saw from the video.
How about we replay it real quick?
We can replay. We can replay. We can
Okay.
replay. Can replay. We can replay. Hey, we got 3 people watching in the live stream. You know, so give a like, give a sub. You know, we in here. This is a learning process, right? This is why that's why we got the video here. It's a learning process to build on our knowledge, to solve LeetCode problems. So yes. All right, let's go for it.
Right. Let me make sure.
Hey, Cheese Fest! Welcome to the stream,
Cheesy.
Cheese Fest.
Cheesy's here.
Welcome to Cheese. Yes, sir. He's
What's up,
here.
Cheese? What's up, Cheese?
We'll have a starting and ending point within the original sequence. So let's modify one of these variables to create a subproblem. Turns out that you can solve this particular problem with either choice, but I personally find focusing on the ending point of a subsequence as a little bit more intuitive. Let's define a subproblem for the sequence as lis at index k, which would mean the
You
longest
let me know when to
increasing subsequence
pause.
ending at index k.
Yeah.
For example, the lis ending at 3 would be the sequence starting at 1, followed by 2, which has a length of 2. Remember that when I am referring to lis in this particular problem, it is specifically with respect to the length of the sequence. Okay, so now that we've identified one possible subproblem, the third step requires finding relationships among subproblems. It often helps to ask yourself questions in this phase. For example, suppose you want to solve the subproblem of finding the longest increasing subsequence ending at index 4. What subproblems are necessary to solve this? Well, the nice thing about this graphical visualization is that it makes it quite clear what subproblems we need. One path through index.
All right. So
All right.
he's saying if you specify an index, but
Yeah.
we're gonna need to go through the whole. If our problem is finding the longest, I think we're still gonna need to go through the whole array.
Yeah. Yeah, and I think he's gonna explain it a little bit further up the thought process. Like he's gonna write it down. So I don't know if
Okay,
you wanna
keep it going.
to. Yeah, a little bit, just a little bit,
Okay,
because I think I know where you're coming from.
okay.
Yep.
So we will need to know the length of the longest increasing subsequence ending at index 0, which happens to be 1. Another path comes through index 1, so we'll need that subproblem as well, which also has length 1. The final possible path ending at index 4 goes through index 3, and the longest increasing subsequence ending at index 3 has length 2. Now the nice relationship here is that the length of the longest increasing subsequence is just going to be 1 plus the max over all the necessary subproblems, which ends up being 3.
Okay,
Okay,
you
so
got that?
here, yes,
I
so
caught it.
here
I
he's
caught it.
basically, yeah, I got it too, where he's gonna basically calculate all of them, right? 3, 1, 8, 2, right? And then he's just gonna get the maximum, right?
But my question is how does he know that those are passed to 5? Like I
Well, because
understand.
you're expanding the square, right? For example,
No,
the
but
square.
he said if we let's use 5 as an example.
Yeah,
Then what are all the paths to 5? And he says 3, 1, 2.
yeah.
So how are we going to know that those are the paths? We're gonna
Okay,
have
I see.
to like what's
Yeah.
the best way? I know what we have to do if that's the case, but like what's the best way to ow. I just hit my foot. What's the what's the what's the best way to figure that out? But this right here at the bottom, this is clear. Like that's clear as day.
Yeah, yeah.
The max one, the max
You're gonna get the max of the different
path
paths that lead up
yes,
to.
plus 1
Yeah.
because the next one from the max path is going to be the 5. So that's why you plus the 1.
Hmm.
But question is, and I know what you're saying, the square, like, oh, you just expand the
Yeah,
square.
yeah, yeah,
But you start at 3, and then you're like,
yeah.
okay, 3, you go to 1, okay, that's not greater than 3, and you go to 8, and then you mark it there. You're like, okay, there's a path, and you
Well,
keep, yeah.
well, the path is based if the number we're looking at is lower than 5. Like 3
Mm.
is lower than 5. 1 is lower than 5. 2 is lower than 5. 8 is not.
Mm.
Don't get confused
Mm.
with the arrows, Papa. Don't get confused with the arrows. Yeah, the arrows are show that that's a sequence. Like 3 and 8, that's a sequence. It's an increasing sequence. 3 and 5, that's an increasing sequence. Right? 1 and 8, that's an increased sequence. Right? So those so the path is determined if the number we're looking at, right, is lower than the number that we want trying to find or search for. I don't know if that makes sense.
The path of the what?
Not like the number, like the path is determined if the number we're currently looking at, right, is lower than the number that we have.
Oh, yes, 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 yes,
Yes.
yes.
See that I think that's how the path is made, right? So
I want to I
mm,
want to give you a caveat though.
yeah,
But we got to apply this to every individual number
yeah,
because
yeah.
2, we need to find the path to 2, which is going to be 1, so 1 to 2, and then 2 to 5. We can't just say, oh, 2. Oh, wait a minute. Oh, ooh,
Well,
ooh.
that's the thing. We can store it though. For example, if we're looking at 5, right? We're looking at 3. 3, it's subsequence of 1, right? We're looking at 3 and 1. Both of them have 1s, right? Because there's no path. 8, however, is going to look at 1 and say, like, is 1 less than 8? Yes. So let me grab the number, which is 1, or the longest, with the value that 1 is storing, right? Which is 1, and I'm at it. So now we have a sequence of 1 and 2, right? Now we go to 2, right? And then we say, hey, 1 and 2 make a path, right? Let me go based on the previous one, which is 1, grab its value, and add it to myself. So now we have 1 as 1 and 2 as 2, right? Now we go to 5, right? 5 is going to look like, all right, I can go to 2, right? 2 can go to 5, right? 1 can go to 5, and 3 go to 5. 3 has a stored value of 1. 1 has a stored value of 1. 2 has stored value of 2, right? So now I'm looking at 1, 1, 2 and say like, hey, which of you are the maximum, right? And I'm gonna go to with 2. Yeah. So it's not like we're going to 5, we're recalculating 1 and 2 again. We're just going based on the numbers we stored already. I don't know if that makes sense. I don't know if that answered your question or even got close to your question.
Um, Okay. Oh, Jose, I don't know if you just said this,
Yeah.
but but oh, I got it, Jose. I got it, Jose.
All right. Let it down. Lay it down. Lay it down on the floor, man. Lay it down.
So, okay. I'm gonna break it down even more. I honestly, I don't know if you just said this, but hopefully you didn't
Yeah.
just say it. But we need to find a way. Okay, we need we need to find a way that will create all the. It sounds so dumb whenever I say it. We need to find a way to mark all these paths in one loop. We loop through it once. We loop through it once. We need to find a way to mark these paths some way or another. right? The
Yeah.
porter, the second loop, we're gonna loop twice. The second loop, well, of course, it's gonna be like a recursion, but I'm just imagining like a loop for right now. The next iteration will be actually looking through it and seeing where the longest path is based off all the paths that you have mapped out.
Well, if we already have them all mapped out, why don't we just get the maximum of all the paths?
That's what I'm saying.
But I don't think we need another second for loop for that.
You think you could do it
We can just
in
store it in a
one loop?
variable. In a um I mean, I'm not sure we can do it in one or two loops, right? But I don't think we need a second loop just to figure out the maximum. I think we can just have like a variable and that keeps track of that.
Why are we having an issue with this? What's going on?
I think it's an interesting problem. I
Like
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 it. I like it.
like he literally gives us the answer right here, and we
Yeah,
didn't
the pseudocode.
the pseudocode. We didn't
I mean,
think
really,
to review that.
I didn't pay attention to that because I
I
was
didn't
like,
pay
you know what?
attention either.
I don't know if Carlos wants to solve it like from scratch, so I'm just
Well,
gonna,
we're trying to
pay attention.
understand it. We're trying to,
Yeah,
and we're using this new little visual
approach. Yeah,
approach, and we can't. Well, me speaking for me, I can't seem to figure out how you. Yes, how you like how this visual gets
represent,
represented in
translate it.
code. Bro, compiled into.
Oh,
So how about we review the pseudocode and see what this guy is talking about?
I
See,
think let's give it. Okay, we
what do you
could do. We
mean?
could look at
What do you mean?
we could look at the pseudocode. Let's look.
Okay,
Okay, let's look at it.
this
I'm
part right
down
here.
for
This part right here. Implementation.
Implementing a dynamic programming solution
Oh, that was really fast.
that. Damn.
I'm gonna slow it down for us. All right.
is just a matter of solving subproblems in the appropriate order. What's most important is that before solving a particular subproblem, all the necessary prerequisite subproblems have been solved. In this problem, the order is actually fairly straightforward. We have to solve the subproblems from left to right. So let's now implement a function.
Yep.
Let's keep track of the lengths with a list. We can initialize all the lengths as 1
Yeah,
since
that makes
every
sense.
increasing subsequence.
So this is saying
That's saying like
every
five.
node
Mhm.
store the length.
It has. Yeah.
It's gonna store the lengths of.
Yeah.
Okay.
Yep.
Okay.
Yep. Yep.
Will have at least one element. Then, for every index from 1 to the length of the input list, we will first find the
Hey, we
destination.
got Otitos,
Hello,
Otitos,
Otito
Otito, Algos,
Algos, Otito,
algorithms,
Otito.
Otito Algos. Hey, don't know how to pronounce your name. I apologize for that. Hey,
Pretty sure you
but
chatting.
yes, sir.
Give us some
Yes, sir.
input. Hey,
Appreciate.
maybe you know more than us. Let us know what you're thinking.
Exactly. Exactly. Hey, we're open ears.
Pretty
Okay,
sure you
okay,
chatting
okay.
now.
Problems.
Yes, sir.
Okay,
Yes,
so
sir.
for I in range from 1 to length
That's
L,
gonna loop through
the lengths, the lengths of the nodes of the path. Yay or nay?
the A.
We update the length according to the
Okay, pause,
generalization
pause,
that
pause,
we have
pause,
specified.
pause. Okay, so we say subproblems. For k in range of I. Okay, let's see. I, what's I? Okay, for I in range of, okay. For k in range of I. If k says an I. Okay. K will equal Alrighty. Okay, that makes sense, maybe. Hmm. Let's see. Uh, so we got K for K in range of I. So from zero, if 0 is less than I, for example, 2 and 8, 2 is less than 8, length K will equal root 2. Hmm. Okay, that makes sense.
Oh, we got an updated name change. Otito Algos.
Eh, Otiro Algos. Hey, I
Okay,
don't
I
understand this algorithm in learning too. Hey, that's what we're here
okay,
for, brother.
okay. Welcome,
That's what
welcome.
we're here for. You know,
Welcome,
um,
welcome.
but we're watching a video midstream, right? Because we don't understand this problem. We're trying to understand dynamic programming, right? Hey, we're in the same boat, brother. You know, just stay strong. Watch some videos like us. You know, a couple problems. Hey, you need to get there, brother. Right? But hey, we appreciate you coming in aboard in this live stream. Yes, sir.
Keep it going.
Yes, sir. Yeah. So,
Okay,
mm,
so for
okay,
Ein range is it's just creating it's just looping. It's not looping in
it's just
anything. It's
looping.
just
Yeah,
looping.
this K is gonna go from 0 all the way to I minus 1.
I
Yeah, it's gonna go to the previous of I. So, for example, I is 1, which is 2.
mm-hmm.
K is gonna be 0. It's gonna end at 0. If I is 2, which is 8, K is gonna loop through 5 and 2.
Okay, and then it checks
Yeah.
if
Yes.
it's gonna oh, I see what's going on here.
Yeah.
It's wait a minute. No, I don't. Yes, okay, so sub problems is gonna get an integer value. No. Yes, no. Yes. No.
Yes.
Yes,
No.
yes.
Yes. Just okay.
Is it? Yes, because
Um.
it's gonna go until it stop. No, I don't get it.
Well, I think subproblems is gonna be an array. It's gonna be an array,
Mm-hmm.
right? Where if k is less than 2, is less than I, for example, let's say I is at 8, which is 2, right?
Yep.
And k is at 0. Yes?
Which is 5.
Yeah.
Yep.
So 5 less than 8. Yes. So length k, so we're gonna go to k, L, get k, which is 0. We're gonna grab 1 and put it in subproblem 1, right? And then we're gonna go to 2, right? 2, 2 less than 8. Yes, same thing. We're gonna go to 1. We're gonna go to L, get that value of 1 and put it in subproblem 1, right? And then I'm not sure. Hmm. Okay, I see. Now we update L. All right, so we update L. So subproblems is pretty much getting like the ones, right? The else, the 8 is getting the path from 5 to 8 and 2 to 8, right? And in subproblems, we already have the 1 from 5 to 8 and the 2 from 2 to 8. Yes?
Mm-hmm.
Yes. And then on L1, right on the second line, that one, the plus one, right? The plus one, that refers to the eight, to the current eight. So we're going to say one, which represents the eight, plus the maximum of subproblems, which is represents the one from the five, the one from the two, right? Get the
Hate to
maximum of those
interrupt
two.
you,
Yeah.
but we also got another sub, and we got a
Oh,
question from
baby.
Alex.
Hey.
Alex.
Uh,
Alex N says, "How do you increase insane level?" Well, let me tell you, mine's increasing currently as we speak. Jose, do you mind letting Alex know how we
yeah.
increase that?
So, to increase the insane level, it's just how stressed and anxious and angry we are at trying to, while in the process of solving LeetCode problems, right? So, for example, in a good day, something like that, we might be, fresh out of a nap, just eating, and we are excited, so our insane level at zero. But as soon as we see the first problem and we see some recursive programming and list comprehensions and lambda and all that stuff and concepts that we don't really know that much about, we tend to get a little bit more stressed out. And the more we dive into those problems, the more stressed out we are, and therefore our insane levels go up. Right, the maximum is 10. We usually cap out at 10, so if one of us hits 10, we kind of call it there. Um, and sometimes, some outside factors, right, might play into the insane level, right? That might be outside programming, such as like bad sleep or whatever the situation it is, right? That
Yeah.
might affect it
If you want
and
to
might
see
increase
if
it a
you
lot
want to see
more.
that in action, you should go to last week's stream. I was
Yeah,
falling
yeah.
asleep on stream
hmm
because I don't know. I forgot what happened. I think I
Playing
think
basketball, I think. You played
oh
basketball
yes,
that
yes,
day.
yes, 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 yes. I played basketball. I didn't sleep at all. I came back and I was dozing off and and I just wanted you to
Yeah,
finish a problem, bro, because I was like, dude, I'm about to go to bed. Like
yeah,
I'm about
yeah,
to crash right now. So anyways, we
yeah,
updated usually after we solve a problem, but um there's definitely times where we update it instantly. If
yeah.
I'm usually me, I usually get upset uh at these problems. Not really upset, but I express my frustration, if you will. So
Yeah.
appreciate you asking the
But
question though.
you say, hey, and also welcome, Alex. Hopefully you stay, and appreciate you being here, brother.
We're
Yes,
almost
sir, yes,
done.
sir.
We
Well,
almost got this damn problem on lock. We just
yeah.
gotta figure out why we need to visualize like this and how are you going to
Ooh,
implement it.
ooh. I work at AWS, which is I think Amazon. Let me say, if you want to increase the incentives quickly, just come to work here. Low. Hey, bet we'll see.
That's
We'll
really
see.
funny.
Yeah,
That's really
we'll
funny.
see. Yeah, we got all the we're getting to practice already.
We're
Yes,
building
sir.
our insane level tolerance. So
Yes,
we're
sir.
good in
Yes,
it.
sir.
We're
And once
tackling
we
it.
get there, we're gonna be ready.
Okay, you good? Are you ready?
Yes. Yeah, I'm good. I'm good.
All right.
Yeah. So,
And now
um,
Oh, my bad. I was gonna play the video.
oh,
That's
I
on
good. I
me.
good.
No, no,
So,
you go. You keep
yeah.
explaining.
Alrighty. So, sub problems is just storing how many connections there is to the number that we're looking at.
Yep.
Yeah. For
Yep.
example, remember we said like the paths are determined if the number we're at is less than the number we have, right?
Yes.
So that's pretty much it. So we're just like kind of storing those paths in sub problems, right? For example, let's take six now. Uh, yeah, six, right? Six I K we start at five, right? So five less than six, yes, and that's one. That's a path of one,
Mm-hmm.
right? So we move one to sub problems, right? Then we do path of two, right? Two, it's a subproblem of six. Yes, it's a less than 6. Yes, so that's 1. We put subproblems into 1. 8 doesn't meet the conditions, right? Boom. So subproblem now has 2 ones, 5 and 2, right? Because 5 can go to 6 and 2 can go to 6, right? So that's 1. It has 2 elements and both of them are ones, right? Now we go to the next line and we say, all right, there's 2 paths to me. There's 2 paths to 6, which are 5 and 2. Get the maximum, right? And since they're both ones, right, we just get 1, right? They don't, it really doesn't matter, right? And then we add a +1 to that.
I have a
And that
question.
+1 represents the 6. Yeah.
So does it, wouldn't it all based on how you explain that? Maybe I'm understanding it correctly. Orcus, what's up? How you doing, man? Long
Yes,
time no see.
sir.
Yes, long time no see, man.
Hey,
We're
Orcos, welcome to the
we
stream,
still have our
brother.
weekly
Welcome to the
stream streak
stream.
alive, man. We
Yes,
stream
sir.
every week for 47 weeks. We're almost at a year. Almost. But anyway,
A
sorry, Jose.
year.
Jose,
I
so
good, I good, I good.
maybe I'm understanding, misinterpreting your explanation, but wouldn't everything be one based on you saying that okay, there's a linkage from 2 to 6, 5 to 6, like there it would always be one. If 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 you're at 9 over here, there's gonna be 3 to 9. That's one. There's gonna be
Okay.
a six
Yes.
to nine. That's one. There's gonna be
E-
an 8 to 9. That's one. So how did?
yeah.
But I'm assuming it gets the previous of.
Yes.
So where does that come into play?
That's on the Li, right? The Li will equal to the maximum, right? So
Oh.
go back to 6, right? So the 6 and the subproblems, we have 1 and 1, which are 5 and 2,
Hmm.
right? We get the maximum, we get 1, right? It's, they're both ones. It doesn't really matter. We get the +1, which represents the 6, right? So now we
Yes.
have
The
2,
two.
right? So I, which is the index of 6, we're going to go to L, right? And say L, position of index of 6, put 2 in there.
Yes. I
So
get
now
it now.
whenever we reference to 6, we say, hey, 6,
That has
we
two
already,
That has
it
two.
has it has a 2 because,
Two.
a path. Yeah,
Because one of the five are the twos plus the six itself.
yeah, yeah. It has a path. Yes, pretty much. Yeah,
Okay.
yeah.
Okay. So
And we just repeat that.
okay, I see, I see. Interesting.
Yes. Yeah, it's pretty interesting. I really like the how intuitive it is. The fact that um we store the paths that way. It's really nice. Really, really nice.
Now I wonder because they mentioned that this like visualization can be applied to other problems, but I just have to see it in action in other problems to kind of understand
Yeah,
how you
yeah,
could translate it. But there's also some other examples, like there's this box stacking one,
yeah,
and he kind of just goes into like as you see here, you you just visualize it, and then you could kind of get like a better understanding. Or you could
yeah.
do this right here, which I thought was pretty cool, and it's like just the path, like you're finding the path, and then you can
Mm-hmm.
easily scope out like, okay, this might be the longest path. It's the only viable option that will make it. So, anyways, I thought it was pretty interesting.
No,
Um,
yeah.
I definitely got to rewatch it though. That's for sure. Because clearly I forgot. But so, do you think we're good here, or what do you think?
I mean, I think I'm good here. I'm good.
You think we're good?
Yeah. Just
All right,
yes.
we're back. Oh, we don't even
All
have
right.
the dang thing.
Yes, sir.
Oh
Hey, I think we lost each other for a sec there.
no, I
I
knew
think
where
we're
you were
back.
at. You lost me.
I think I lost you.
Yeah,
Yeah.
yeah. You lost me.
I think I lost you.
Yeah,
Yeah,
yeah. I didn't lose you though.
but I think I'm back. I think I'm back. I think I'm back.
Okay, can you see
Yes, yes,
everything?
yes. All right. Yeah, yeah, back. Yeah. All
Okay.
right. I can see everything. Yes, sir.
So I kind of wanted to figure out: are we ready to kind of implement it, or do we need do we need
I mean,
to?
I think I'm good. I think I have a good understanding.
Okay.
But up to you, brother.
Okay. Well, if you have a good understanding, I got a great understanding.
Okay. 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 Alrighty. So
So we want to
we
create
need a
that.
way to.
Keep going.
Huh?
Keep going.
Okay. So we need a way to store the paths, right?
Okay.
And then we need a for loop, right? That starts at index one, right?
Isn't it it loops through the length of nums?
Yes. From range of one to lengths of nums, I think.
Okay.
Yeah. So we need that, and then we need a
Inside that.
list, a sub problems,
Okay.
which is gonna be a list comprehension.
Okay.
Comprehension,
Did I
right?
spell that wrong? Probably.
I think you spelled it right. I think you're right. You're right. You're right.
And
You're right.
then
And then
update
update stored
paths.
paths.
Mm-hmm.
Yeah. And then return the
Return max
maximum.
path.
Yeah.
Okay.
Yep. Yep. Yep.
Do you want to call this like
I'll say paths maybe,
paths equals?
and then you can do
They
bracket
said
one
that
times.
they said do a default value, correct?
We can do one. I think.
One. Okay.
Yeah.
One times the length of nums.
Yeah, and I think it's gonna be bracket one bracket, and then the one inside the brackets. Uh huh. Uh huh. Okay. Now we have that stored in.
Okay.
And we need to loop through it for I in range of one to length over nums. Yes. Right. So here we need list comprehension. We're going to call it sub problems. You want it. Yeah.
Okay.
Right. And then it's gonna equal to
Uh,
wait. You
I don't
put in
know.
no.
What's up? What's up?
It's go
Right side.
one to the left. Yeah, paths at position K.
Dude, I don't know how
And
to
it's
do
gonna
list
go.
comprehension.
I got you, brother. I
Okay.
got you.
Okay. Okay.
So we go to the right and go
Hmm.
for K in range of I, right? Then go to the right and do if if
Paths. No, no, no.
no nums I think nums position K
Okay.
is less
Listen.
than nums at position I.
I.
Yeah, and then yeah, that's pretty much it. And then we say paths at position I will equal
One
to
plus max sub.
yeah.
And we don't need a that default that they had. We don't.
Uh, I don't
Well,
think we need it.
default is 0, but we put 1 in here. So
Yeah, I think we should be good then. We should be good.
okay.
Yeah, and then we return max paths. And I think the list comprehension is good. You want to run it? Ufas. Uh, arguments in empty sequence. I think we do need a default equals 0. Okay. Okay. Okay.
What happened? Oh, wasn't there so I wish everyone who comes across this message attains their dream job in 2024.
Hey, hope that's great.
Should be classified as hard. Test cases, there you are. I knew you
Yep,
were
yep,
here.
yep, yep.
Copy. Okay. Please.
Okay. They're passed. Alrighty.
Do I dare submit?
I would say so. I would say so. You know. Ufas, bro. You got scared there.
I did get scared. I did get scared.
Hey, we solved it. Let's go. That's fun. That's
There's a
interesting.
caveat though. We know we had to learn.
We had
We
to
learned
learn.
a little
Yeah, we
bit.
had to learn.
So I'm gonna put
Yeah.
like you could put a note. You could put a note. Uh we cheated.
We did actually. We learned from it, right? I think we learned. I think mm, we learned more. I think we were more learning how to do dynamic programming than how to do this problem.
I see what you're saying. Like
You know what
like
I'm
we
saying?
didn't we didn't just get
We
info
didn't go
that
for.
solves this problem specifically, but we got more info that helps us
Yeah,
with multiple problems in the
yeah.
future.
I think we. I
Also,
think
we
we
got
went
another
into the.
sub.
We got another sub.
Yes.
Yo, if
We
you just sub,
appreciate y'all. We
leave
appreciate y'all
leave
subbing.
a
Yeah,
leave a
hey, you know
chat.
what?
Leave a
If
chat.
you sub, leave a comment. Let us know you sub.
Yeah, 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 yeah.
Please.
Come on.
Don't be shy.
Yes, sir. No, we're glad to give you a shout out, you know.
But anyways,
Yes,
what were you saying?
sir. No, I feel like we saw the video more to learn how to do dynamic programming than to uh figure out how to solve the problem, right?
Yeah.
So I understood the problem phenomenal. I loved it. Amazing.
Okay. Phenomenal.
Yeah,
Amazing.
no,
Okay, Jose. Well,
amazing.
the important question is maybe Alex is still here, but the important question is where you at,
Yes,
man?
sir.
Insane level. Like, what are you
Oof.
feeling? How are
I'm
you
actually pretty
feeling?
good. I'm a
What's
three.
been going
I'm a
on? You're
three.
three? Three
I'm
out
a
of
three,
10?
you know,
Okay.
I like what you say, we cannot be at 0 after finishing one problem.
No, no, no,
I think you
no.
mentioned there,
We respect the game. Like,
respect. There you go. We respect
we
the
don't
game.
we
We have
don't
to be honest.
disrespect like they should be like, oh, I'm not that
Yeah,
insane, like I'm not feeling
yeah.
nothing, you know,
Nah,
like
come on, man.
nah,
Come on, man.
we don't do
Come on.
that.
That's fake. That's fake.
Yeah, that's fake. That is fake.
Yeah, that is fake.
So
So of
three,
course, like you
you
said,
say a
respect
three?
the game. I'm a three. I'm a three. Yeah.
Okay. You know, I will say earlier I was pretty high. I was like maybe like high in insane levels. Let me
Ooh,
clarify that.
fast.
I was maybe like at a five. And then we kind of broke
Okay.
down the pseudocode a little bit more, and then I understood it. So I think that brought me down a little bit. So I think I'm at a four.
Okay. Okay.
Yeah,
That's
I'm
good.
at a
That's
four.
good.
I'm
That's
at a
good.
four.
That's good.
Yeah.
Okay. Okay. Okay.
So I
I
was
like that.
up,
I like.
and then I went a little bit down. You know?
Yeah. Yeah.
Yeah.
All
So
right.
let me see.
Hey, I'm
Now
glad.
let's go back. Let's go back to the neat code.
So I
stuff.
was looking
What happened?
I'm looking at the problems, right? And the
Hmm.
reason I think the reason we left the trees is because we got two hard problems in there, right? We saw the two hard problems and we just say, hey, no, no, no,
Yeah,
right?
we said okay, we're gonna go down this whole list in order,
Yeah,
and then
but nah,
we got
nah.
these, and then we saw this, and we're like, oh, you know what?
Yeah,
Let's go
we
ahead
were
and
out.
skip, and we skipped over here. Dude, it's been a while. We've been doing
Yeah, so
dynamic
we,
programming for a while.
yeah, yeah, yeah. But
What are you gonna say?
I was gonna say, what about graphs?
What about
I
them?
think we worked with the graphs before, right?
Uh-huh.
And I don't know if you want to go back to the original plan of starting from the top, going to the bottom, or you want to jump in, try something new, something that we're a little bit more comfortable
How
with.
about this? How about this? Now
Yeah.
I got an idea. Next week, let's start graphs. Right now, let's boost our self-esteem a little bit, at least speaking
Okay.
for myself. And let's do like a problem, like we could look through the LeetCode problems and just do one that we feel like we could solve fairly
Okay.
easy. Because all these
Okay. That's
problems
fine.
that we've done here, from my experience, they're more like a learning experience. Like it's
Yeah.
like each one is very unique, and like
Yeah.
a unique type of problem that has similarities to the previous ones in the list,
Yeah.
but
Yeah. Yeah.
not so easy to recognize. And I feel
Okay.
like if we select our own problem in LeetCode, we can maybe find one that we could solve fairly easily.
Pretty fairly easy. Alrighty. Alrighty. So
Okay.
what do you want to work in? What's
So
the
let's go and look in the problems list and see, and we could time it. You know what? We'll make a little competition. Not
Okay.
like
Okay.
competition between me and you, but like, we'll put like a timer. We'll set a time. Uh, we do have 5 people watching. Maybe they could suggest
Yes, sir.
amount of
Yeah,
time,
suggest some problems. Some
or
problems that we can
not suggest a problem, but suggest the time
oh,
limit that we
oh,
should
okay. Time limit.
abide by.
Fair, fair, fair.
But okay, what kind of problem you thinking? We got all
I'm
these.
down to do anything, my guy. Let's see. You want to do something with a high acceptance rate? You know, a little
Yeah.
bit.
Okay. Yeah.
'Cause I know. No, no, I said that because I know you said you would do something that we could like think we can do, right?
Okay, okay. Boost the
Yeah.
self-esteem.
So
Okay, yes, yes,
boost
yes.
the self-esteem. So
Yes,
that's why I
yes.
said like a little bit of high esteem. A little bit of what's it called?
High acceptance.
Yeah, high acceptance. Yeah.
Okay.
Um,
I mean, which one sounds interesting to you? Right here, we got
I mean, I'm down for. Let's see. Let's see.
number of good pairs sound really interesting to me.
Number of good pairs. Okay.
Yeah, that's just me
Okay.
personally.
What number is that?
1512.
1512. Okay. What's the premise? Let's see.
Oh, you want me to click it?
I mean, oh, I have it put up on mine, on
Oh,
my
okay, okay.
on my window. Yeah, 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 yeah,
Okay.
yeah. That way we can have like expand a little bit more on the search.
Oh, I see what you're saying.
Uh,
So I mean, does this one look interesting to you, or
Let me see. A pair IJs cut good if IJ and okay. We can do. I think we can do this one. This one is
I
you
thought
know,
we did something like this before. Maybe I remember these requirements somewhere. If they're equal,
okay.
but the index or.
Yeah.
But
We
anyways,
can we
okay.
can we can put it on. You want to do this one? I'm
Yeah,
down.
let's do it. Let's do it.
All right. All right. All right.
Okay.
All right.
Any last chance? Anyone want to comment a time frame that we need to solve this question by? Please, in the next minute, put down your idea. We'll put a little timer right
Yep.
here. Can you
Yep. Yep.
set a
Yep.
time or? So it's almost like solving a Rubik's cube. Like you gotta You got a timer. Try to beat it within that time, dude. While we wait for the next minute, I'm gonna talk to you about what I'm thinking about getting right
All
now.
right.
Thinking about
Okay.
getting some food, bro.
Ooh,
I've been
Fuzz, what's in the
addicted.
menu? What?
I've been addicted to Wingstop, bro.
Bro, I just had Wingstop yesterday,
You're
bro, and I feel
lying.
you. I feel you, bro. I got Wingstop yesterday, bro, and I feel you, bro.
You had the cheese or
Dude,
no?
the cheese. Oh, the cheese, brother.
But you dip it with the wings, though.
I dip it with the wings,
That's
dude.
crazy.
Ah, trust me,
Whoa,
bro.
we got a suggestion.
Ooh,
Ali says 5
yeah.
minutes.
Minutes eat,
Okay.
bro.
Whew.
Ifas.
Okay. I think we could do it in
Ufas.
5. I think we could do it in 5.
I think we can do it in 5 too. I think we can do it
Yeah.
in 5 too.
I think we could do it in 5.
I think we 5 too. All right.
Okay.
Hey, but finish your
So
story with the
anyways, okay,
Wingstop, bro.
okay. So you know,
What's
you
in the
finish
menu?
your story. You're getting me hungry.
Oh,
So
dude.
you got
You
it
know,
with
cause
cheese.
I got it with cheese. I got it with cheese. And this time I tried the mild, and I've had the mild before, but the mild, bro, bro, the mild. I know like wings are supposed to be spicy and all, bro, but the mild, bro, is like perfect, dude. It's phenomenal. It's amazing. I love mild,
You
bro.
you mean to tell me that
Yeah.
you don't get like any hot flavor other than mild?
I can't support hot flavor,
You
brother.
can't support hot.
I can't support hot. Yeah. I'm all like, bro, like
Uh-huh.
all breathing through my mouth and everything.
So
And I mean,
what did you
uh-huh.
usually get? You're a lemon pepper type of
And
person
lemon
or
pepper and parmesan. Yeah,
parmesan?
lemon pepper and parmesan.
I might do the lemon
But
pepper today.
bro, lemon pepper, bro, ufas. Bro, yesterday I got the 6 piece, right? I got lemon pepper and mild. And I got the cheese. And I got the ranch with the fries, bro. Ooh, with the sweet tea, bro. The sweet tea from Wingstop, bro. You're
Sweet
missing out,
tea.
bro. Sweet tea from Wingstop, bro, is amazing, brother. It's good, bro. Trust me, it's good.
I can't get behind that. I don't even get a bev.
What? Oh, you don't get a bev,
I
bro?
don't get a
Ooh,
bev.
what?
No.
Oh, damn.
Yeah.
Damn, bro.
You know
I
what
mean,
kind? Okay.
alright,
And
okay.
um, to kind of match like the. Let me see. In timer intense intense music. Okay. I'll put on some. Uh, let me see. That's not it. No,
Oh,
that's not it.
damn.
That's not it. That's not it. That's a
Damn,
trailer.
bro.
That was a
Going to
trailer. That was a
war or something
trailer.
like that.
Okay, ready?
Bro, this is some Game of Thrones stuff.
You ready? 5 minutes on the
Oh, we're
clock.
going. Okay.
Ready?
We going. Okay, okay.
Three.
Yeah, yeah,
Wait, do we
yeah.
want to read it first or no?
I mean, I understood it already.
Okay.
Think I know. Oh, wait.
Okay.
Oh, fast. I'm trying to think if we. Uh, let's see. 5203. Wait. Oh, they're the indices.
Yeah.
Okay. Okay. Yes, I got it. I think we got it.
We got it?
I think we got it. Yes,
Okay.
yes, yes, yes,
Ready?
yes.
Five
You ready?
minutes.
You ready?
Starting now. Okay.
Okay.
So what are you
So we
thinking?
need 2 for loops. One
Two
for
for
loop, two loop.
loops?
Yeah,
Okay.
yeah, yeah.
I'm
For
following you.
loop.
4.
Yeah, 4 in range of
And
0 all the way to the length of nums. God, trust me,
okay.
brother. Trust me.
I'm
All right,
trusting
so
you. I'm
we got
trusting you.
that. Create another for loop with j now in range. Same thing. 0 length of nums. Same thing. And
Okay.
then we're gonna create if statement. Okay, we need a counter. So we need a counter outside for both for loops. Create a counter, right? Boom. Set it to 0. We're gonna say counter. Yeah.
No, if.
We
If.
need. Okay.
Right?
Yes. Yeah. If nums at position I is less than position j, or we can do less than or equal.
Well, it's supposed to be
Yeah.
equal.
I mean, it could be less than or equal. Oh, okay, I get you. Okay, yes. Then n and I equals less than j, and no, we need one more end. We need one more end, and I is not equal yeah to j, right? And then
Okay.
we're gonna
Which isn't
yeah then we
that
go
isn't that I less than J?
well I less than j I not j prevents that we're doing the same number,
Okay.
right? Yeah, and then we're gonna do counter plus plus or counter plus equals 1, and then we return counter.
At the end?
Yeah. Then we run that. Trust me, bro. Trust me, bro.
Do we need test
Trust me.
cases or no?
Let's go. I mean, we got time to do some test
Okay.
cases.
Okay, test cases.
Oh, okay. We got that one.
Go. Go.
Run it. Okay. Run it. Run it.
All right, I'm
Okay.
confident. You ready?
Okay. Submit it. Hey,
Good stuff. Good
yes,
stuff.
sir.
Good
Yes,
stuff.
sir. We got it.
Good stuff,
We
man.
got it. People be restricting us to 5 minutes. Bro.
That was really nice.
Nah.
Really
Nice. It was
nice.
nice. We got it, though. We
I
got
was
it.
letting
Good
you lead
job,
the
brother.
way. I was letting you lead the way. You already had it in your head. I was thinking a hash map.
A hashing. Okay. How would that work?
Yeah.
Let's see. Let's work it out.
I was thinking that well, I don't know. I didn't think of the approach yet, but I just thought like, oh, let's use a hash map and store um how many pairs there are.
Okay. Okay. Hash map. But how would you set up the hash map though? Like, what would be the keys and values?
That's a very good question.
Yeah.
That's like probably the greatest question you've ever asked. Dude, there's only 6 people do. Oh, okay. There's 11
11
people doing
people.
this. Okay, okay.
11 people. Sir.
All right. Well,
Yeah. I mean,
that was it for me.
alrighty. Yeah. I was gonna
You
ask
wanna?
you if you
What's up? What's
wanna
up?
like optimize it a little, try to optimize it a little
Okay,
bit.
optimize it.
I don't know.
Okay, yes, yes, yes.
Yeah. Because I know we just be like 5% when it comes to time. So I want to know like if there's a way to optimize it or look at a some posts and see what solutions uh they can provide us, right? But let's see. So if we understand the problem first, I and j has to be equal or less than j. Okay. Okay. I mean, what if, right?
I got it. I got it. I got it.
Okay.
Okay. Actually, maybe. Ready? Hear
All
me out.
right. Yeah.
The key is gonna be the value of it,
Okay. Yeah.
and the key is gonna be the element number. The value is gonna be if it's a pair with anything. So so everything's gonna have 0, right?
Okay.
Let me think. Let me think. Okay, yes. So you go through. You just loop once. One, You're gonna put it in the dictionary. So 1, 1 or whatever. 1:1, right? Two. Okay, you're gonna put there's one in the list. Three, there's one in the list. One, oh, one's already in the dictionary. Let's add it. So since there's two, that's a pair, right? Anything
Okay.
above one is gonna be a pair. So then there's another one, three. Okay, now there's two pairs. And then you got three right here.
Yeah, okay, I see. Yeah, yeah, I see
What
you.
is? Wait, 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 wait,
Yes.
wait, wait. Where's four pairs though? Oh yes, yes, three. Okay, so one, two. No, no. One, two, three. Where's there four? Two and. Am I not doing this right?
I think it's one and the first one, right? And then the first one with the second one, which that's two.
Okay, so it's this one and this one.
2 and 5.
Zero,
Oh, wait.
3, 0, 4.
Oh, and 3 and 4, 3 and 4. Like when the ones that are together, they're a pair, considered a pair too. Like next to the first three, that one and the
Oh
other
yes,
one.
yes,
Yeah,
yes,
yeah,
yes.
yeah.
So would that be 1, 2, 3? That'll still be 3. Interesting.
Well,
No, like the
oh,
my approach that
oh,
I thought
okay,
of.
okay, yeah.
So like if I put this one in there, I put this one in there, 2, and then this is 1, 2. That would be 1, so that's 3. Okay, yeah, ignore that then.
I was thinking on splitting the array in half, right? We have I in the beginning and J in the middle,
Mm-hmm.
right? Oh
Okay.
no, that can't work. Whoa, we have uh oh no, never mind. That wouldn't work. Not sure how would we
Well, maybe there's a workaround. Okay, so I'm thinking if you have an odd number, if you have an odd number, then technically there's 3 pairs. There's
okay.
3 there's 3 pairs. If you have an even number, then that's just 1 pair.
Okay. Think I'm getting you. I'm not sure.
So so you so you put all the ones in a dictionary, all the threes, all the twos. Any key value pair that has in the value side that has more than one value, those
Hmm.
enter the pool of pairs. And from there, we check the numbers of those values. So for one, it has a total of 3, right? 3, because
Yeah.
we inputted 3 ones in there in the dictionary. Since that's an odd number, I'm imagining like you do modulo 2, and then you get the remainder, which would be 1. That
Okay.
that remainder of 1, if it's a remainder of 1, then you can add an extra, like if you're using a counter, you can add an extra 1 to the counter because that would technically be another pair. Um
Okay.
Another
So
pair
you okay.
possibility.
Yes,
If
yes,
you
yes, yes.
modulo 2 and you get a 0, then then that's just whatever the amount that's in there, you just you divide it by 2, and however many times you divide by 2, that's how many pairs you got. Yeah or nay? But I don't know if that's more optimized, but that's just another.
Yeah, so you're trying to okay, so you be okay, I think I get you. I think I get you. So you're saying like store all the frequencies, right?
Mm-hmm.
And then um hmm, I'm thinking. What if, right?
What if?
Mm, we okay, let me see, let me think. So we have one as the key, right? But since it's the first one, we just add a +1, right? Okay, never mind. No, that wouldn't work. Yeah. Well, yes. For example, we check if there's no value in the hash map. If there's no value in the hash map, we create a key, right? For one. Once we
Yes.
create the key, we add a +1. And now once we add the other twos, right? 2 plus 1, that's 3. So that's giving us our 3. Because if we have 3 ones, we have three possibilities or three pairs, three good pairs, right? I don't know if I'm making sense.
You said if we had 3 ones, we have 3 good pairs.
Yeah, it's because what I'm saying is like, right? The issue here is our ones or the key or the value that the key of one is gonna have is 2, right? It's not gonna take into consideration the extra one, right?
Why not?
Um,
Why not?
well, because I mean, because we're not counting the one we're entering.
Yeah, we are.
We are okay, so
Mm-hmm.
that gives us 3, right?
Yes.
3 in the dictionary. Okay, and then okay, that gives us 3. Okay, I take it back then. I take it back
Okay.
because let me see. Let me see. We have 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Hmm.
Hmm. I think it was. I think it could work, but there's definitely
Yeah, a little
a
hiccup.
little trick that I'm doing to kind of solve another problem that you
Yeah,
encounter with that approach. And the way I'm thinking
yeah,
about it
yeah,
is like you modulo, and each time you basically like you divide by 2, and you keep dividing. Every time you divide by 2, then you add a counter.
yeah,
You
yep,
add
yep, yep.
+1. And if there's a remainder of 1, then you add another to that counter. But if it's a remainder of 0, then you don't. Then you just count how
Oh,
many
what would you
twos
do
you
the
divide.
remainder for? Are you gonna looking for that extra?
Excuse me?
Why you or why are you doing the remainder?
Because
I got a little confused there. Then you lost me, completely lost me.
because that will still be a oh. The way I thought
Because
about it is that you got 3, right? So you got a 1, 1, that's 1 pair. And you got 1, 1, that's 2, and then 1, 1, that's 3. So I was
yeah,
thinking the remainder would be you just add, if there's a remainder, then you just add that there's a pair. But I just thought about it, and what if there's 4? And you do 1, 1, 1, 1. No, what if there's 5? Sorry. If there's 5, let me do it over here.
well, if it's 5, that's 1, 1,
1,
2, 3, 4, 5, 6, 7, 8, 9, 10.
like if there's 5, it's not as easy as you add the remainder at the end, is what I'm saying.
Yeah,
If it's 5,
yep,
this is going to need to be added to all the other numbers that are possible. Like, so, oh man, scratching my
I mean,
brain,
you
bro.
put it in on the test case and see what it prints out.
Okay. Oh yes, yes, yes.
10. Hmm.
And if you do the divide by two method that I was thinking, you would do one, two. So you have two counter, and then see now that's not valid. Like the approach that I was thinking. So no, my approach is tarnished. Okay, I have a question. Hear me out. They have contribute a test case right here, right? But it only benefits LeetCode to implement those test cases that we can't see. Why
What do you
can't
mean?
it, like, if someone contributes a test case,
Uh
like
huh.
I'm imagining this guy down here that always does the test cases. There's like a this one.
Uh huh.
Like he could totally, I don't know, maybe he does, but he could totally put this as a
On
contributed
the
test case.
GitHub. No wonder.
Wait, now you got me. What are you talking about? Actually, let me finish what I was
Like,
gonna say.
okay, yes, 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 yes.
So he could contribute a test case. Oh,
That's why he always has test cases, cause he contribute them.
are you saying that contributing a test case goes into GitHub or it goes into,
It goes into LeetCode, right?
but we're not able to
Into
see the
the
test case? Like, my question is,
yeah.
if I contribute a test case, will others be able to see that this is a contributed test case, or will just LeetCode just use it for their benefit to test us? Like, if it's a good test case, they will just test us as one of the test cases that it tests. Does that make sense?
I think it's just
So,
gonna benefit LeetCode.
so then my question is why isn't there a way that we could see some of these contributed test cases like how this guy does it down here? We got to look through the comments to find him, give us the suggestion. But if people are contributing test cases, and like, why can't we get that option to see like, oh, contributed test cases? Like, like that should be a tab.
Yeah.
So hey, that's all I'm saying.
No, I get you.
I
I
don't want
get
to
you.
talk too much smack right now. I'm in a happy mood. I don't want to
You're in a
ruin the
happy
night.
mood.
Yeah, I'm in a happy mood.
Hey, I
So
get brother.
you know
No,
me.
but
I like to find flaws in some systems. But
no, but I do get you though, because it's a little bit unfair, right, for league code to take out like credit and not say like, oh, this was contributed by, you know, this specific person.
well, not just that. It's just like, let me see the contributes that people have been like doing. Like, oh, I want to see a section just so like I could have some test cases of my own to test, and not like
Yeah,
not even
scroll.
be a
Okay.
scroll and like maybe someone put a test case down here that we could use. But now that I'm thinking about it, maybe it's our job to figure out what kind of um uh base
Approach or
case
yeah,
or edge cases there are, to where as a developer you need to have that kind of mindset to think
yeah,
of
yeah.
edge cases, and if you're given them, then maybe
It won't
that could
really.
kind of not really
Yeah, it
benefit
will.
you if you're just given.
I get
So
that approach too.
I see both sides. I see both sides. All right,
Sure.
Jose,
All right,
Wingstop
brother.
closes in an hour, bro.
Okay, brother. We can end it up here then.
I
So,
need to make sure I go get
uh,
that,
I'll get you, brother, bro.
because if I
Damn, bro. Hey,
don't,
leave
I'm
some
gonna
for
be
me,
upset.
brother. Leave some for me.
Hey, I'm still waiting for your tamales you're gonna give me.
Hey, I got you, bro. I got you. They're here. They're here already. Sounding safe. Sounding safe.
Nah, I
I
don't
got
know.
you.
I
Don't
think you've
worry.
been eating them on the side.
Ah, man, bro, I'm
You're
so
like,
hungry, bro.
bro, like I don't. I guess I chose the wrong bag. These are only four. I'm be like, bro, you serious? Nah, for real though, how many am I getting?
A dozen. A dozen.
Let's go.
A dozen. Yeah, I
Let's
made sure. I made sure. I
go.
made sure. I made sure.
I
Yes,
appreciate that.
sir.
What flavor is
Of
it?
course, brother. Beef. Carne.
Okay,
Yeah.
okay,
Yeah, yeah.
okay.
Yes,
I
yes,
could do with
yes.
that. That sounds
Yeah, I
really
was
good. I'm
gonna
excited.
Yeah, no, I was gonna get you some like different types of like tamales, but mom didn't really. She just went in there, boom, 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 packages them up and gives it to me,
Okay.
right?
She
So
didn't
like I
approve
didn't
of
really
that
have a
message.
yeah,
She
yeah,
didn't
no, I didn't
approve.
even have time to tell her.
Oh, okay,
So
okay.
she's yeah, yeah,
No,
yeah.
no, no. I think I'm very. Either way, I'm grateful. So it doesn't matter.
No,
Whatever
of
you got
course,
me, you
brother.
got me.
Of
But
course, of
I would have
course.
been less grateful if it was bean and cheese.
Oh man, bro,
I ain't
bro,
gonna lie to you. I
you
ain't gonna
say
lie to you like
that right
that.
now. You say that right now. You say that right now. You
I ain't
say
gonna
that
lie
right
to
now.
you.
But damn, bro, damn, bro. Hopefully,
I'm
Wings
gonna
Up
still.
closes
I'm.
like.
I'm gonna still be. I will still be grateful, but I'll be less grateful if it was
Oh,
bean and cheese.
damn, damn, damn. That's rough.
There's levels to gratefulness.
There's levels to gratefulness, damn,
Yeah.
bro.
You know,
So
not
I won't
every
trust you then. I won't
not
trust you then.
not
Every
all
time you say thank
gratefuls
you, be like,
are equal.
fair
You'll
enough.
learn that. You'll learn that.
You do have a point there, but now
You
that
know,
makes me,
there's a base
question all the.
case. There's a base case gracefulness, but there's more optimized and
There's
more
more levels.
advanced, more levels to the grateful.
Damn.
Yeah.
Okay. Okay. Fair enough.
So
Fair enough.
that's how I see it. I don't know.
Yeah.
Maybe if you're
No, I mean,
grateful, maybe you're equally as grateful for everything. But
no. I mean, it's the same thing with happiness. There's different types of happiness, right?
yeah, yeah, yeah.
Yeah. Yeah.
There's
Yeah.
levels to it. But like I said,
Exactly.
at the end of the
Exactly.
day, I'm still grateful. Like there's
Exactly. Yeah. Yeah. Yeah.
now being
And that's what
ungrateful.
matters.
Now if you gave me bean and cheese and I was like, bro, like I don't
Yeah.
like
That'd
bean
be.
and cheese,
Yeah. Yeah.
then you're like ungrateful.
Yeah.
But I
As
would
long
see
as
it.
you.
I would see it. I'd be like, oh, bro, I appreciate you. And then whenever I get home, like I'm throwing it away. I'm joking.
Oh, damn.
That's a joke, bro. Come on now. Now that was a joke.
Oh, I'm gonna keep the mileage now, pal.
No,
Just
no,
because you
that was
said
a
that.
joke. That was a joke.
You said that.
I
Nah, I
will
get
eat
you.
it in
I'll
front
get
of
like.
your face to show you how grateful I am.
All right.
I'm
Fair
sure they're
enough.
not even that bad. I'm just a hater, bro.
No, it's because you haven't tried them, so you know
I tried a little
it.
piece before.
Oh, yeah, yeah, yeah. I get you. I get you. I get
Yeah.
you. No, but
Yeah,
they're
it's because like growing up, like I never had bean and cheese tamales before. Always like chicken,
yeah,
pork.
yeah,
That's basically it. Chicken, pork, and
yeah,
then there was a place that started selling tamales. Well, they always been around, but we started getting it from them. And then my mom
yeah.
said, "Oh, like they got like pork and cheese, and they got
Okay,
hot pork, spicy chicken." I'm
okay,
like, "What?
okay.
Spicy
Damn,
chicken?"
that's
And
some
then I
crazy
was like,
combos.
you know, and I thought about it. I was like, bro, like what is that? Like I want my pork and chicken, you know. But then I tried it and I'm like, wait a minute, this sounds pretty good. Like
Eh,
this pretty
yeah,
good, tastes pretty good. And then
yeah,
but she mentioned there's bean and cheese and that's where I'm at right now. Is
yeah.
I think I tried a little
Well,
piece, but then I was very against it.
yeah, but I mean, it's because I don't know what type of cheese they use there, but we use the white cheese. We
Or
use
use
like
the
the
white cheese. Is that the one that
yeah.
crumbles really quick?
No, well, I
No.
mean, there's different types of white cheeses. There's the one that's like a little bit solid, right, and that doesn't crumble. You know,
Is it the one that's
it's a
like
little bit more.
liquidy? Like not liquidy, but it's more like it's
It's more
glistening.
condensed. Yeah, a little bit.
No,
Yeah,
it's like it's
yeah.
very shiny
Yes,
and a
yes,
little
yeah.
bit more like squishy.
Yeah,
Okay,
and it doesn't crumble that fast.
doesn't
Yes, we
crumble,
use
but
that
it's
type
squish.
of
Well,
cheese.
what is it
Yeah.
called?
I forgot.
Like, what's the
It's
type of cheese called? Not like the like. Do you know what you would call it?
not sure. I forgot. I know there's a name, but I forgot the name of it. Yeah.
Because what's the
I
one
just
that
know
crumbles? What's the cheese that crumbles?
of to be honest, bro, you caught
Bro,
me there.
lock in.
Bro,
Isn't it called like dude? If you let me guess this right and you don't get it, you should be ashamed.
bro.
Um, what is it
No,
called? It's called
is queso de
no, I don't know it.
because I know queso de
Fresco?
cabo.
No, that's not Fresco.
No,
What's the one that crumbles really easily? It's that white cheese crumbles.
Yeah, yeah, I know which one you're talking. I
That's
love
it.
that one. I like.
That's it.
No, you
I'm searching it
going
up.
to the web,
White cheese
that
Mexican.
crumble.
This one.
Yeah.
What is this?
Uh,
Oh, I think
to
they
be
just call
honest,
it
bro,
like queso blanco or something. And like, right?
it's because it doesn't, because there's different types. There's queso de cabra, queso de
Queso
vaca.
fresco. There you go. No,
Yeah,
that's not what
but
you call it.
nah,
Okay, but the one you're talking about is the. I know
it's
it's
the
not this one. It's
yeah, it's the one right there. The brief tour of the one that with the blue plate on the left, on the
left.
left.
This
There,
one.
yeah, there we go. That one. Yes, 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 yes.
Okay, so normal cheese.
Uh,
I said so normal cheese.
normal cheese. Yeah,
Normal
normal
white
cheese.
cheese.
No yellow cheese. Nah, nah, nah. Yellow cheese. We don't deal with that. We don't deal with that.
No, whoa.
But
Why no
it's because
yellow
yellow cheese.
cheese?
It's more like a Tex-Mex type.
Ah,
The yellow cheese. Yeah, it's a little bit of
we're
Tex-Mex.
against the Tex-Mex.
We're not, but it's like people see it as like Mexican food, but it's not really Mexican food. It's
Okay.
Tex-Mex.
What kind of people
Yeah,
see it
man.
as Mexican food?
I mean, like northern people, like people from the north,
Oh, okay,
like
okay.
far away from like the border and right where like, cause like in San Antonio, you go to like these like Mexican foods,
Uh-huh.
right? And then like if you ask for enchiladas, right? Enchiladas they have yellow cheese,
Yes.
right? But if you go to Mexico, they got white cheese,
Yes.
right? And these enchiladas they use like, I don't know if you know mole. It's like that
Oh,
brown
I tried it
brown
before,
sauce.
but I don't think I liked it, man. I'm sorry.
Yeah. Hey, all good, all good. Well, they use that like mole to make enchiladas
Yeah, that one.
here, and they call it, yeah. But over there, we use more like chile. We use more of peppers.
Mm,
Forgot what type of pepper we use, but we use peppers and they're red, right?
red
So
peppers.
yeah, so it's a little bit of a
How
misconception,
can
right?
you
But
apply
like
this to coding?
that is true, bro. We're our coding channel.
People are joining
uh,
right now. They're
just
like,
join in,
"Oh, I'm
bro.
about
What
to
is
learn
this,
I'm about
bro?
to watch these noobs do some LeetCode or whatever," and they get on and they're just seeing
Let's
Mexican
see, like
food,
Mexican
enchiladas,
food.
cheese. Crazy, man.
Damn. Nah,
What?
bro. I don't.
Oh,
I haven't seen that. I haven't seen that.
oh,
That's nah.
hell nah.
That's crazy, bro.
What? That chicken's not seasoned, bro.
Bro, that's plain chicken, bro.
Yo,
Yeah.
who's
Hey, bro.
whose worm
Mexican
is
money
this, bro?
lizard?
Oh, it's a lizard.
Yeah. Yo, what is it?
Yo, Jose.
Uh,
This is.
that's
You know
nah.
what
We
that
don't.
looks
We
like?
don't.
You know what this looks like? It looks like
Uh. Oh. Yeah. It does. It does.
right? It looks like that.
Yeah. Maybe that's where they got it. You know.
Maybe. No, but it's a lizard though.
Yeah. No. Yeah. But this. Yeah. The other one didn't have like a. The other one
Alright.
was a worm.
Alright, I'm done. I'm
Damn,
done.
bro. All right, brother. So, if you want to cut it here, so you can get your wing stop, you
Yeah, I'm
know.
gonna go get it right now. Yo,
Hey,
Ali says a bit off track, mate. Dennis says,
hey.
"Los, what's up?" Jeremy, what's up? Hey, I don't know if that's a joke, but that's funny if it is a joke. It's actually funny if it's not a joke. Sorry, it's funny if it's not a joke because you know how Jeremy thinks said you look like him or whatever.
Yeah, yeah.
That was funny.
Jeremy, what? Damn, bro.
Hey man,
I just
y'all just look alike.
yeah. I just have to grow the little mustache, bro. You turn it in a little bit, and bam, I'm Jeremy 2.0.
Yeah.
Easy, easy, easy.
All right, bro.
All right,
I'm
brother.
gonna
So,
I'm gonna head out, man. It was a good
Yeah,
stream. Great stream, man.
it was. I like it. I liked it a lot. It was pretty nice, pretty chill. Something light, right? But if you want, I can do the outro
Yeah,
and cut it
do it, bro.
out there.
Do the
All
outro.
right, boys. All right, guys. Thank you guys for coming in, tuning in. It was a joke.
Oh, okay.
Thank you guys for tuning in. For this live stream. Thank you guys for the people that subbed. We increased 4 subs today, so thank you. Appreciate you guys. Hopefully, you guys stay here, enjoy the time with us. You know, and with all
Should
said
I
and
get
done,
wings or should I just get the fries?
oh, get the wings, bro. Get the wings, bro.
Well, how
I'm
much?
telling you, bro. Uh, I mean, I'm good with the 6 piece, right? But it is true that it's late at night, and once you eat something good, go to sleep, bro. That stomach starts like gurgling and stirring, bro. So I would say, you know, go a little bit low
From
today.
your experience
For
only.
my experience,
Do I
yes,
get
for my experience.
cheese?
Oh, try the cheese, bro. Try the
I'm
cheese,
not
bro.
dipping it. I'm not dipping it with the wings,
Try
bro.
it, bro. Bro, next time we go to Wingstop, next time, bro, I'm gonna make you try it.
Nah.
I'm gonna make you
Anyways,
try it.
sorry, I didn't mean to
I get it.
interrupt
I
your
get it.
outro. Keep going.
I get it. I get it. So thank you guys for tuning in. Have a great day, great night, whatever time zone it is. So, but yeah, just have